So this is our parent function x squared. And what we want to do is remember that we have y, and please type this in your Chromebooks as well. Type a and start your parentheses, x minus h, close your parentheses, shift 6, put your 2, plus k. And then it's asking you if you want to add the slider for a, h, and k. And the answer is yes, we're going to select all. And that gives us little sliders, okay? And then what I want you to do is turn off, well, let's change the color for the parent function is in blue, okay? So in order to make this match, I need to slide. Remember, h does the left to right and k does. So a needs to be 1, h needs to be 0, k needs to be 0 to map to the parent function, right? And so our equation, what was the first number on our equation? It was 3 times x minus 4 squared minus 2, right? So let's go back here. Let's change a to 3. 1, 2, 3. Now, what did that do to that red line? Did you see what it did? Yeah, it stretches it vertically. It makes it skinnier because it's stretching it. So think of like a piece of bubble gum or silly putty. When you take silly putty and you stretch it like this, it gets skinnier and you're stretching. So that's what the a term does. Now h was minus 4, but remember the formula has the minus sign in it. So h was technically 4. And we're going to verify all this. Now, what is this thing doing as I slide the slider to the right? My graph's sliding too, isn't it? And then k was a negative 2. So that's shifting it down. All right? Now, if I did all my math right, and I'm going to change this one here, our original equation was 3 times the quantity x minus 4 squared minus 2. And that's right, right? So now, here's the thing. Notice that the vertex occurs at 4, comma, negative 2. Well, isn't that h, comma, k? Now, here's another interesting thing. Let's go ahead and let me show you something. Let's put in some tables of values because it's really important to me that you understand what this line represents. This line represents numbers that get plugged into this equation. Okay? And so we know that when x is equal to 4, y equals negative 2. Right? So that's a dot on the line. Let me change this to, what color we want this? Orange? Yeah, we'll do orange. Okay? Well, let's do another one. Let's do, in this one I'm gonna fire up my fancy calculator. And you guys can fire up your fancy calculators if you want to, but if not, you don't have to, just watch me. So on my fancy calculator, give me a number that we want to plug into our equation. So remember, it's 3 times the quantity x. Give me a number for x. 13. Good Lord. Let's make it a little bit smaller because we want it to fit on the graph. Huh? Let's keep it close to 4. So let's do 5. Minus, 5. Let me make this a little more reasonable. 5 minus 4 raised to the 2 minus 2. So what I'm doing is, this is our original equation, but I'm plugging in 5 for x. You guys see that? Now hit enter, and it's 1. In other words, when x equals 5, my y value would equal 1. See how that point is on the line? Now let's go one number over here to the left in the x direction. Let's say 3. So let's plug in 3. So I go back to my fancy calculator. If you guys want the fancy calculators in their cardboard box on the bookshelf, well, you can just watch. So now if I say 3 times 3 minus 4 squared minus 2, I get 1. Okay? So when it equals 3, I get 1. See the symmetry there? Give me another number you want to try. That's close to 4, not too far away.
-2.
Well, we want it, so -2 would work, but we want it to fit on our graph. So think in terms of the x-axis. How about +2? Let's try +2. Again, we plug this into our fancy calculator. We're going to say 3 times the quantity 2 minus 4 squared minus 2. Oh, it's 10. So when x equals 2, y equals 10. Now, if I go one more unit over, in other words, if I say x equals 6, look at the graph, watch this. If I go over 5 and then 6, where does this cross the graph? At 10, right? At 10. So I think it's going to be 10 because there's symmetry in the graph. All right, let's see. 3 times the quantity 6 minus 4 squared minus 2. It's 10. Okay? So do me a favor, make sure that you write down this equation, sketch the graph, plot these points. We're going to label all these points, 2, 10, 3, 1, 4, -2, 5, 1, and then 6, 10. Also, I want you to graph, I want you to sketch the numbers, the ordered pairs. And I'll leave that up there for a second. Now, for any quadratic you do, it's going to have this line of symmetry that goes through the x-axis. Or not x-axis, the x-coordinate of the vertex. So what is the x-coordinate of the vertex? Well, let's label the vertex. It's 4, -2. And so on a parabola, on a quadratic, the vertex is the lowest point of the graph or the highest point of the graph, depending on if it opens up or if it opens down. Real quick, when does it open down? What causes that graph to flip upside down? If what becomes a negative? Huh? Yeah, if the A term becomes a negative